Okay. Up till now, we have discussed about fundamental concept of matrix. Simply just entered into the course contents, and in the last classes, we have discussed about definition of a matrix and how it is defined, and it is just the arrangement of some elements within first and third bracket in certain rows and columns. This was the definition of matrix, and then order of matrix, that is number of rows and columns indicate the order of matrix. First component indicates rows and second component indicates columns. If it is 5 by 3, then 5 rows are there and 3 columns are there. If 2 by 3 is order of a matrix, we will understand 2 rows are there and 3 columns are there. So simply this is the order of the matrix. And then types of matrices we discussed, and various types were there. That's like square matrix, unit matrix, identity, that means, and diagonal matrix, scalar matrix, null matrix. So all these types we have discussed in the last class, and today now we are going to discuss about the equality of a matrix. First of all, we are going to discuss about equality of two matrices. How we can say two matrices are equal? What condition has to be fulfilled? What condition has to be fulfilled for two matrices to be equal? First of all, we have to observe the matrix, two matrices to be equal, we must have at first same order. Orders of the matrices to be checked or to be defined as equal, order must be same. So two matrices are said to be equal, first of all, if their orders are same, number one, and number two, every corresponding element of the matrices must be same, must be equal. Corresponding matrix, corresponding elements means, you see here, uh, definition you can understand very simple. First of all, two matrices must be of same order, first condition, and second condition is their corresponding element must be equal. Here, for example, written in this line, if you observe here, uh, 2301 and here 2301. Very distinctly, we can say these two matrices are equal because there are four elements and in each of the matrices. Here, two rows and two columns. That means order of this matrix is 2 by 2. And order of this another matrix is also 2 by 2. That means orders of the matrices are same. So first condition is satisfied. Secondly, we have to observe corresponding. Corresponding means this first element, that is A11 position. This is A11 position. 11 means first row, first column. So this A11 position, and in the next matrix A11 position is this one. That means this is called corresponding position. This is A11 and this is also A11 position. So this is called corresponding position. So whatever elements are here, we can say corresponding element. So in A11 position 2 is here, in the another matrix also 2 is here. It is in the second element of the first row 3, that is 2, sorry, 1 2. A12 position, and here also it is A12. 12 means lies in the first row and in the second column. So its corresponding position is this. That means its corresponding element is this. So corresponding elements are here same, that equal. So if all this position, say here 0 it is, its corresponding position 0. Here it is 1, its corresponding position here also it is 1. So that means corresponding elements are same. So thus two conditions are satisfied. So we can say the matrices are equal. So order must be same and corresponding elements must be equal. Here in this another example, if you say here, this is 3 by 2 matrix, that is 3 rows are here and 2 columns are here. So 3 by 2 matrix. This is also 3 by 2 matrix. Now this matrix equal this matrix or not, we cannot say, because here unknowns are there. That means some variables are used here. So we cannot say these two matrices are equal, but orders are same. But we cannot say these two matrices are equal. But if these two matrices are given to be equal, that means this matrix is equal to this matrix, it is given like equation. If this matrix is equal to this matrix, it is given us, then we can definitely, by the definition of equality of two matrices, we can say corresponding elements are equal, we know. So in this A11 position, x is here, in its corresponding position, minus 1.5 is here. That means corresponding elements are same in equal matrix. So since these two matrices are equal, so by definition of equality, we can say corresponding elements are equal. So that's why the value of x will be minus 1.5. Value of y will be its corresponding element 0. So y will be 0. Similarly, z is here 2 1 position, and here 2 1 position element is lying 2. So z is equal to 2. So in this position there is 2 2. A 2 2 position. A is lying in the same corresponding position, root 6 is here. So A is equal to root 6. We can write A is equal to root 6. Similarly, B equal to 3 and C is equal to 2. Why we can write so? Because matrices are equal, it is given. Since two matrices are equal, so we can write its corresponding elements are equal. But if it is not given, we cannot say these two matrices are equal until and unless we know the values, all the values of these variables. If it is given, then we can equate corresponding elements. If it is not given to be equal, we cannot say. Just very basic numerical example. Here you see in this example, this is a matrix which elements are just small expression in terms of variables and constants. In this matrix, if you observe, 3 rows are here and 3 columns are here. That means order is 3 by 3. In the right side, again it is 3 by 3 matrix. These two matrices are equal or not, we do not have any perception, because elements are in terms of elements are in terms of variables and constant. Someone is waiting in lobby. Okay, this little bit problem to update. Anyway, in this example, as I said you, in the example it is mentioned If means it is given to be equal. This is equal to this. That means this matrix equal to this matrix. If this matrix equal to this matrix, that means left hand side matrix is equal to right hand side matrix. If that means it is given two matrices to be equal, then what to do? Find the values of A, B, C, X, Y, and Z. These variables are involved with the uh, elements. So we need to find all these values. Very simple. The concept of equality of two matrices we can go through directly. These matrices are equal given, so corresponding elements are equal we can consider. So since these matrices are equal, so we can write x plus 3, that is the first element A11, and this element is equal to this element, corresponding element. X plus 3 equal to 0. Similarly, z plus 4 is equal to 6. Similarly, twice y minus 7 is equal to thrice y minus 2. In the second row, if you observe, minus 6 is equal to minus 6. This number, we can say, yeah, these two elements are equal. A minus 1 is equal to minus 3. 0 is equal to 3c plus 2. B minus 3 is equal to twice b plus 4. Minus 21 is equal to minus 21. No problem. Right definition. 0 is equal to 0. Some numbers are kept equal here. So, I do not have any problem. So, thus equating corresponding elements, we will have some small linear equation. Small linear equation of single variable. So we do not have any problem to write the values of the variable concerned directly without any difficulties. X plus 3 is equal to 0, that means this relation. From this we can write x is equal to minus 3. Z plus 4 is equal to 6. So directly you can write z is equal to, it would be minus 2, plus 2, and twice y minus 7 is equal to thrice y minus 2. From this relation, only single variable y is here, so we can find the value of y will be here, y, then it is plus 2, so minus 5, so y will be minus 5. So from this simple linear equation of single variable, we can have the values directly, and the values are like this: a equal to minus 2, b equal to minus 7, c is equal to minus 1, x is equal to minus 3, y is equal to minus 5, z is equal to 2. It's a very simple and basic uh, numerical example. When two matrices are equal, that means given, then we can find the variables concerned with the elements. Very simple example using the concept of equality of matrices. In the next example, if you observe here this one, exactly same concept, similar problem. It is two rows are here, two columns are here. It is 2 by 2. Again, it is 2 by 2. Order same, and equal it is given, and the values of a, b, c, and d from the following equation. Equal sign is here, variable concern, order same, so we can say it's an equation. So exactly with the previous one, we can write, since these two matrices are equal, so twice a plus b is equal to corresponding element 4, a minus twice b equal to its corresponding element minus 3, and 5c minus d, its corresponding is 11. 4c plus thrice d is equal to 24. So exactly similar with the previous example. Just one difference is here, that is, if you observe carefully, twice a plus b is equal to 4. So this is a equation, linear equation, but two variables concerned, a and b is concerned. Twice a plus b is equal to 4. We cannot write the value of a or b directly from this equation. So all these relations, a minus twice b is equal to minus 2. Again, a relation involving two unknowns, a and b. 5c minus d is equal to 11. Again, another relation in terms of C and D, not single. Next, last one, 4C plus thrice D is equal to 24. Again, it is another relation in terms of two variables. That means linear equation, but two variables. And linear equation, two variables already you have got how to solve. And in the last standard, that is in class 10, class 11, 12, linear equation of two variables, very simple. These four equations we got it from equating the corresponding elements, these four relations. And from these four relations, simply you can solve the values of A and B. If we solve these two equations, because it is A and B in terms of AB, and this equation also in terms of AB, just simply we can solve these two. And similarly, C, D are here, and in this equation also consists of two unknowns, C and D. So we can solve these two equations for C and D. So thus we can have all the unknowns A, B, C and D from these relations. So this is the way how we have to find the values of unknowns concerned with the elements. But elements matrices must be given to be equal so that we can compare corresponding elements. Now it is a small exercise here. If you are interested, then you can note down a few exercises from my side. If you want to note down, you can note it here. As I discussed in the last class, that we have to construct a matrix of order 2 by 2, and the matrix elements are defined as this. This is 1, and this is 2, and this is 3. So three examples are here in the question number 4. Here the elements are defined in this way. So using this defined rule, we can have all the elements of the matrix. So how we have to construct the matrix, we discussed in detail in the last class. Similarly, this one very simple, and this one, and question number 5 also you can go through, and question number 6 just the equality of matrices. Just few seconds back we have discussed question number 6, equality of matrices related basic examples. So two matrices are equal. We have to write the values of the variable here. Here also it is 2 by 2, and it is column matrix. A single column is here, and here also single column is here, right hand side. So just equating, matrices are given to be equal. Just equating the corresponding elements, we can have relations, and solving that relations, we can find the values of the variables. So very simple, very basic examples. You can go through this particular example just for practice, or to um, be more clear. Okay, these few examples you can note down, and you can go through this, very simple. Next, another topic, operations of matrices. Operations of matrices means matrix is so new for those students who didn't have earlier. For them, it is quite new. So since it is new and it is not a particular value, it is a structure, actually arrangement, particular arrangement. So how it is handled It's a new algebra, new thing. So when you started learning numbers, rational numbers, natural numbers, integers, counting numbers, all these numbers concept when you started earlier in class preschool or class 1, 2 level, then after knowing the numbers, you learn about operation. That means how the numbers are handled through some operations. So similarly, since it is new, so these new things we have to handle through some operations, and this operation basically how two matrices are added, how two matrices are subtracted, what conditions to be fulfilled for the matrices to be added or to be subtracted, and multiplication matrix when two matrices are allowed to be multiplied, and whether a matrix can be multiplied with a uh, scalar. Scalar means any number or any constant, not in matrix form, the scalar. So whether a matrix can be multiplied by a scalar or not, so which is called scalar multiplication. And matrix multiplication means when two matrices are allowed to multiply, and how to multiply two matrices. So no division is here. A matrix cannot be divided by another matrix. So matrix division is not there, does not exist, because these are not value actually. So multiplication is allowed through some certain rules. So these operations we are going to discuss through these contents. First of all, addition, and parallelly we can say subtraction also. First of all, when addition holds, that means when addition can be performed between two matrices or more than two matrices, that is called the condition to be fulfilled for matrix addition. First of all, order. So order is the basic element to know about the structure of a matrix. So conditions basically depends on uh, order of matrices. So in addition also, exactly like equality, addition also, orders of the matrices to be added must be same. If orders of two matrices are same, then it is allowed to add. This is the one and only one condition. Orders must be same to be added. So through example, it would be clear very nicely, because very simple phenomenon. A matrix is considered here, say A. First row, second row, two rows are here. First column, second column, third column, three columns are here. So its order is 2 by 3. B, another matrix. Two rows are there and three columns are there. So 2 by 3. That means orders of A and B same. So to add these two matrices, condition is sufficient. Just their orders are same, so we can add them. Now how to add? Very simple. Corresponding elements to be added. We have to add corresponding elements. We have to add corresponding elements. So in A, first element, A11 position, that is root 3. And in its corresponding position in B matrix, element is 2. So To perform A plus B, we have to have another matrix adding A and B. And in that matrix, element will be, first element will be root 3 plus 2. That is, we have done just added the corresponding elements. Root 3 plus 2. 1, its corresponding position element in B is root 5. So 1 plus root 5. This is minus 1. Its corresponding place is this in B. That is also 1. So minus 1 plus 1. 2, similarly 2 plus minus 2. 3 plus its corresponding, again it is 3. 3 plus 3. 0 plus its corresponding element half. So 0 plus half. So if we write this in a new matrix form, then we will be having A plus B is equal to this one. And 1 minus 1 is 0 written here. And 3 plus 3 is 6 is written here. 2 minus 2, 0 is written here. Because this can be simplified. So simplification is very necessary. Because we can simplify. If we can add two numbers, so the result should be written. So 2 plus root 3, we cannot add this. It is just irrational number. 1 is rational number. So it is not necessary to express in decimal form. So this is the resultant matrix, which is obtained adding the matrices A and B. So here I can mention for your confidence, because exactly similar concept for subtraction also. Here in these examples, if we need to find A minus B, it is given here A plus B. If we need to find A minus B, then also similar procedure. Like in addition, we add corresponding elements, and in subtraction, we have to subtract corresponding elements. And for that also, condition of the matrices remain same. That means orders of the matrices must be same. In addition, simply we add the corresponding elements, and in subtraction, simply we have to subtract the corresponding elements. And doing so, whatever matrix we get, that's called the resultant matrix of two matrices. If it is addition, then it is A plus B, and if it is subtraction, then we will get the resultant matrix A minus B. So nothing difference regarding these two operations, way of doing for addition and subtraction. It's very simple and similar. Thus corresponding elements we have to add, or we have to subtract. Why the matrices to be of same order? Because if we observe here in this example, suppose in matrix A there is another column here. Just imagine here 1, 2, 3. 3 columns are here. You just imagine another column is here. That means 3 rows or 2 rows are there, but 4 columns are there. So third column, this is another column here. You just imagine. Then you see order of this matrix A will be then 2 by 4, because 4 columns are there. 2 rows are there and 4 columns are there. So its order is 2 by 4. On the other hand, in the matrix B, 2 by 3. That means orders are different. So if orders are different, then what problem arises? Let's observe. This, imagine fourth column is here, suppose. Then what happened? Its corresponding element is this 2. And for this element, corresponding element will be this root 5. For this minus 1 element, its corresponding element will be 1. And in the fourth column, suppose here some element is there definitely. If you imagine another column here, suppose A and B, suppose small a small b are they are considered. Okay, so this element, that means A, what will be the corresponding element in B? So no corresponding element will exist in B because orders of A and B are different. So fourth column is here and there is no fourth column. So therefore corresponding element does not exist. So if corresponding elements do not exist, then neither we can add them nor we can subtract them. So to exist first corresponding elements, orders of the matrices to be added or to be subtracted must be same. Orders of the matrices to be added or to be subtracted must be same. Otherwise, corresponding elements will not exist here. So that's why this is the only condition to be fulfilled for addition and subtraction of two matrices. And next, the multiplication of a matrix by scalar. Scalar means, as I told you, just a constant or a number. It is not matrix form. On the other hand, there is a matrix. So a matrix can be multiplied by a scalar. So how is it allowed? How is it allowed? Matrix multiplication means multiplication between two matrices, and scalar matrix multiplication means a matrix and a scalar. That means one is matrix and another is non-matrix. Between two expressions, whether it is possible or not. So, or how a matrix is multiplied by a scalar. So, that's all for today's session. And in the next class, we'll be discussing about matrix multiplication, two types. One is by scalar and another is matrix by another matrix. So next operation multiplication will be discussed in the next session. Thank you for joining the class. And again,
Thank you.
I'll be telling you that